Hi you guys, today we're going to solve a system by substitution. So yesterday we solved a system by graphing. We graphed both of those lines and we looked to see where they intersect, and today we're going to solve it a different way. You know I don't love graphing just because I have to get graph paper and then I have to see, do these lines, unless it's a perfect, really pretty point, it's difficult for me to tell where it is. So this is another way that you can solve a system. Now think, yesterday our answer to our system was a coordinate. So just because we're solving it a different way, we should still get the same answer. We should get a coordinate for our answer, or an ordered pair. Okay, so here's my two equations. So I'm gonna have two lines and they're gonna intersect somewhere, and that's the part that we care about. However, we're not gonna look at a graph, okay? So step one, set one of the equations equal to x or y. So that means we want one of these equations to say x equals or y equals. And look, right here it does. This first equation says y equals, so we're good to go. Plug that into the other equation. So just think of substitute. Like if I have a substitute teacher, she's replacing me when I'm not here. So this is the same thing. I'm gonna take this other equation right here, 3x minus 8y equals 4. And I'm going to substitute this part right here, 6x plus 7. I'm saying that's the same thing as y. Those two things equal each other. So instead of saying y, I can say this. They're the same thing. So I'm going to write this out again, but instead of putting y, I'm going to substitute this part into y because they're the same thing. All right, so I've taken out the y and I've put in the 6x plus 7. All right, now I'm going to clean up this side because it looks a little messy. I'm gonna have to distribute my negative 8. So 3x minus 48x minus 56. All right, I'm still gonna clean this up. I'm gonna combine these like terms. Negative 48x minus 56. Oh, I'm sorry. Minus 45x, because I'm combining those, minus 56 equals 4. Now I'm going to solve this. I want x by itself. So I'm going to get rid of this guy first, add 56 to both sides, which gets me 60. Whoops, I forgot my x. And then divide both sides by 45, negative 45. Okay, not pretty, not what I was hoping for, but that's okay. We can see what number goes into 60 and 45. I know that, oh my gosh. I know that 15 goes into both of them. So if I divide this by 15, I get 4. And if I divide this by 15, I get 3. So x equals negative 4/3. Now remember, it doesn't matter if the negative's on the top, in front, or the bottom. They all mean the same thing. Okay, so remember, wait a second. Oh, I did a lot of work. I feel like I'm done, but I am not done because my answer needs to be a coordinate. So I'm gonna put my answer down here. And guess what? I only have the x value, negative 4/3, which we don't love, right? Fraction, but it's gonna be okay. So negative 4/3 is my x value. I know that because it says x there. So now what I have to do, I did all that work, I figured out my x. Now I have to plug my answer back into either equation. So I'm gonna pick which one looks easier, obviously. So the first one looks easier to me because if I plug an x number in here, I just have to do that calculation. I don't have to really move too much stuff around. Okay, so y equals 6x plus 7, and now I'm gonna substitute my answer for x. So I'm gonna substitute that into the x spot. So y equals 6, and then parentheses, negative 4/3 plus 7. Okay, now all I have to do is this calculation. Well, okay, I like cross-canceling. I would cross-cancel that. That turns into a 1, that turns into a 2. 2 times negative 4 is negative 8. If you are not a fan of cross-canceling, you would say 6 times negative 4 is negative 24, divided by 3 is 8, negative 8, okay? And so y equals negative 1. And now I have my coordinate. So basically we're saying these two lines intersect at this coordinate, okay? Let's try another one. On this problem, you can see, oh, now instead of it saying y equals, it says x equals, but same philosophy here. I'm just gonna take this equation And instead of writing x, I'm going to substitute that into the x spot. Y plus 6, so I'm just pulling the x out and I'm putting that in. Okay, I'm going to combine my like terms here. Now I'm just solving this equation. Subtract 6 from both sides. Divide by 2. So y equals 2. Now remember, my answer needs to be a coordinate. So my answer is going, and that's the y value is 2. So I'm going to plug this back into either equation. Well, I'm going to plug it back into this equation. X equals 2 plus 6. So x equals 8. And I can also check this, right? I can say, okay, if when I look back here, I can say the x was 8. 8 plus 2 is 10. Good. And then the y is 2. 2 plus 6 is 8. Okay, so that is the system. So when you're checking, it needs to work for both of them. So don't just plug them into one. You need to plug them into both to see if it works. Okay, this question I had not originally put on, but I wanted to show you an example of what happens if neither one are set equal to x or y. Okay, it's not too tricky. All you have to do is make one that way. So let's rewrite this. This one seems a lot easier to convert to me. So I'm gonna set this equal to y or x. It doesn't matter. Let me just choose y. Okay, so I'm gonna subtract x from both sides. So I'm gonna say y equals 5 minus x. Okay, those are the same thing. I subtracted x from both sides. All right, so that's my first equation. And my second equation, I'm just going to leave it like this. All right, so now the same thing. Now I have this as y equals. So I'm going to write this equation down here. 2x minus y equals negative 2. And now I'm going to plug this in for my y. 2x minus, plug in my y. 5 minus x equals negative 2. Now I have to distribute that negative. 2x minus 5 plus x equals negative 2. Combine my like terms. 3x minus 5 equals negative 2. Now I'm just solving. Add 5 to both sides. 3x equals 3. And x equals 1. Remember, I'm not finished yet. That is the x value. And now I can plug it in. I can plug it into either one. Well, I still think the top one is a little bit easier to plug it into. I like to plug it back into my original. Okay, so I'm going to say x plus y equals 5. Plug my 1 in. 1 plus y equals 5. Subtract 1 from both sides. Y equals 4. Okay? All right, this problem has a little bit of a twist to it, so I was going to have you go ahead and do it without me, but I want to show you something here. Okay, so on this problem, it looks fine. Oh, good. One of the equations is set equal to y. So I'm going to write this equation down. And then I'm going to plug in this in the spot of the y. I'm going to substitute it in. So 6x minus 2. And then in my parentheses, I'm plugging in what y equals. Distribute my negative 2. Look what's happening here. I have 6x take away 6x, so that's totally gone. And now I have negative 2 equals negative 2. So if I end up with something like this, the x is gone, there's no x's, there's no y's, there's just negative 2 equals negative 2. That's a true statement. So if that's a true statement, it means it's infinitely many solutions. Because if I had to picture this, what that means is I have a line and then I have a line over it. These two lines are the same exact lines, so they intersect everywhere. Okay, so if that is a true statement, now if that was not a true statement, if it said negative 2 equals 2, which is not true, it would mean the lines are parallel and they are never going to intersect anywhere. Okay? All right, let's mosey on to this one over here. Same thing. You try this one and you can freeze it and then catch back up with me if you want. I'm going to plug my y value in. So I have 2x plus y. Just going to write this down. I don't like putting plus a negative. Minus 2x plus 5 equals 5. Notice what happens here. Same thing. They cancel out. So 5 equals 5. So that, once again, is infinite solutions. All right, I want to show you an example over here about Nate and a business. Let's say it's a lawn business and he has expenses. And what I like about equations like this or problems like this is they're giving us the equation, and they're not going to give you a wrong equation unless they flat out say it's a wrong equation. So his expenses cost this much. His revenue is this much. So this is how much he's spending. If he has a lawnmower business, let's say he has to buy the lawnmower, he has to pay for gas. So that's his expenses, and and he's bringing in this much money for every lawn he mows. When will the revenue exceed the expenses? Well, notice I can do the same thing. I'm going to write one of the equations because they're both equal to y. Substitute that into the y spot. 25y equals, 25x, because y equals 25x, equals 2x plus 200. Subtract 2x from both sides. I get 23x equals 200. Divide both sides by 23. I didn't calculate it for that. 200 divided by 23. I get 8.7 once I round. So basically, after, let's say this is weeks, after 8.7 weeks, it's going to end up matching. Well, what I'm trying to do is find out what week will the revenue exceed the expenses. So your answer would be week 9. At week 9, he'd be good to go with money. All right, last question for today. We have a Fun Time Park. They cost $12.50 for admission and 75 cents a ride. So right now, my mind starts working. One-time fee, reoccurring fee. So I know my equation here is y equals 0.75x plus 12.5. Here, River Park, $18.50 for admission and 50 cents a ride. Right now, I start figuring it out. What is the number of rides that the park will cost? So the park will cost the same. So if I go on one ride right now, if I went on one ride, this park would cost a lot more because look at the entrance fee. If I went on 20 rides, maybe this park would end up being more. So that's what we're trying to figure out. How many rides would it take for them to be the same? So we can, since they both equal y, I can set them equal to each other. 0.75x plus 12.5 equals 0.5x plus 18.5, okay? I'm gonna subtract 0.5x from both sides. So now I have 0.25x. And now I'm gonna subtract 12.5 from both sides. And now I'm gonna divide both sides by 0.25. And my answer is 24. So at 24 rides, these parks will cost the same amount. Okay? All right, we'll see you guys tomorrow and we'll talk about a different way to solve functions. To solve systems of equations.